Why do people go bald?
Why are baboons' bums red?
What's a light year? Why do leaves go brown in the autumn? Why do monkeys like bananas? Why do some things glow in the dark? Why do animals not understand you? Why do my receipts fade after a year?
Don't know the answer? Ask the Naked Scientists.
Hello and welcome to this week's Ask the Naked Scientist with me, Sue Marchant, and Chris Smith. Anne from Ages Green, who's just gorgeous, she says that she's got a question about goose drippings. She would like to know what Dr. Chris's thoughts are on it, the dripping in general. Anne is a great fan of it. But what do you reckon? Is it good for you? Is it great or, in moderation?
No, like all things that taste great, it's very bad for you. Actually, it's derived from the subcutaneous fat of the bird. So when you roast the goose, the skin has underneath the skin surface a layer of fat, just like humans do. And because fat melts when it gets hot, when you put it in the oven and the heat goes up, then the fat melts and it drips out and you collect it, and that's just saturated fat. And like all animal fats, it is saturated fat, and that means it's bad for you. Actually, saturated fat increases cholesterol in the bloodstream. This is linked to the formation of atheroma, the furring up of blood vessels, and therefore it will place you at risk of vascular disease if you overdo it. But it's like all these things, it's in moderation, isn't it? So if you lived on that stuff, that would be bad. But now and then, like all these things, if you just do it now and then, it's not going to do you very much harm.
All right, something I avoid anyway, so that's okay. Now then, Sean in Beccles wants to know what makes people like some foods and not others. Why do some people hate Brussels sprouts and some people really enjoy them? Is it to do with signals from the brain?
Well, it's definitely down to personal taste. And interestingly, there was a case written up about 10 or 15 years ago of a pair of girls that were conjoined twins. Only these girls were very interesting because unlike most conjoined twins who are just joined one small part of the body, actually these girls were joined virtually for the whole of their body. So they had two separate heads, but they merged somewhere about halfway down their body. And interestingly, when one of them got unwell, the other one could take medicine for her because, of course, they share a circulation. And one of them liked the medicine and the one who was ill didn't like it. And so the one that was unwell didn't have to take the medicine because her sister took it for her, because it just went from one, got absorbed and into the other. And they did have different tastes in food. And so it shows it's nothing to do with the fact that what's downstream of your stomach. It's all to do with what's in the mind, because these are effectively two people sharing one body, and they both had very unique tastes and likes and dislikes. So it's all down to your own personal experience, how you are brought up, because if you're brought up to be very gregarious in your eating habits and you try lots of different things and you become very accustomed to eating different flavours, then that will make a difference. And to a certain extent also, it may be down to genes. What we now understand is that there are certain people in the population who are what are called super tasters. They have certain genes which encode the chemical receptors in the tongue and the nose for certain flavours, and these genes encode receptors, chemical docking stations, that are much more powerful than the average person. They lock on to specific flavours much more tightly than in the average person, and consequently they experience stronger flavour sensations for the same foods as another person. And the consequence of that is that some foods that contain some flavourants to which these people are very sensitive, and this includes green leafy vegetables like cabbage and Brussels sprouts and broccoli, these individuals find these things very, very unpleasant. And as a result, they tend to avoid them. You tend to find this gene more commonly amongst people from Asian origins, but they crop up in all populations. So if some people really don't like their greens, it could be down to their genes. So from greens to genes.
Scary stuff. All right, well, we've got Christine, who's on the telephone from Burnham-on-Crouch. Hello, Christine.
Hello there. Hello, Chris.
Christine, hello.
Yeah, hello. What I wanted to know, like Sue, I mean, Sue's vegetarian, as I am, and I just wondered, because I like the soya and the corn, like your sausages and the burgers, and I just wondered, with the fat and that in them, are they any lot more healthy than eating meat, or are they just as unhealthy?
Well, it depends where the fat comes from. Of course, if they're genuinely vegetarian, they should have only plant-derived oils in them.
Yes.
And plant oils, unlike animal fats, which are fully saturated, and what that means, animal fat consists of lots of carbon atoms linked together. In fact, palmitic acid is characteristic of animal fat, stearic acid. These are lots of carbon atoms linked together with single bonds. And that means they're saturated. They're saturated because you can't add anything else to the carbon atoms because they already have all their bonds full up.
I see.
Plant bonds, on the other hand, plant oils, are unsaturated. In some cases, like olive oil, they're mono-unsaturated, and that means that in the carbon chain, they might have, say, 20 carbon atoms in a line. One of the carbon atoms has a double bond between it and the next carbon atom. And that double bond makes it a different shape, so the molecule is a different shape, and it also makes it chemically much more reactive. Olive oil is like this. This seems to be consistent with better health. Other plants are polyunsaturated. That means that in the molecule there are lots of these double bonds which twist the shape of the molecule, and they make it a different shape, and they also make it more chemically reactive. These polyunsaturates and monounsaturates are better for you than saturated fat, animal fat. And so therefore eating plant-derived oils seems to be consistent with a lower risk of high blood pressure and heart disease and stroke than eating animal fats.
Right. Mind you, I do wonder if some of these things they contain a lot of seasoning and salt sometimes. You know, some of the sort of ready prepared things that you buy. You know what I mean?
Indeed, and they often make up for a lack of good quality texture and flavour by adding absolutely loads of salt.
Yeah.
So you have to be really careful about that.
Yeah.
I must say I'm really careful. I'm not a big lover of them because every time I've cooked them, they've just gone like cardboard, you know. And so I tend to just do my own stuff actually.
The key thing, Christine, with any kind of diet like that, humans are omnivorous, and we do need a good source of iron and a good balanced diet.
Yeah,
so if you're eschewing meat, it's really important to make sure that when you eat a non-meat based diet that there's a source of iron in there, because especially for young girls, because lots of people decide to become a vegetarian when they're in their teens, when the body's demand for iron and other trace nutrients goes through the roof because the body's trying to grow, also menstruation's kicking in, and it's very easy for young women to get iron deficient. And there was a study done in London a few years back where they found that they did an IQ test on a bunch of girls, and they found that their IQ was too low. And when they did a blood test on them, they also found their haemoglobin was too low because they didn't have enough iron. When they put them on iron tablets and also gave them some dietary advice, because these girls were all vegetarians, their IQ went up by several points immediately.
Really? What about
so
older
it's really
women?
important. Well, the thing with older
I'm
women...
an older woman.
The thing is, as you get
I
older,
do
of
take
course, one of the
vitamin pills.
well, that can help. And one of the things that also happens as you get older is that women also go through the menopause, so they stop menstruating.
Yes,
and women, unlike men are often full up with iron. They don't have any need to take iron pills or anything, but women often live very close to the iron breadline, so to speak.
Really,
They're just about have enough iron in their body because they're losing iron all the time, every month. And when you go through the menopause, then you stop losing that iron, so you become more like a man. You have an iron replete status, and therefore your iron demand drops. So it's mainly younger people, growing people, girls who are trying to grow muscle, and also grow brain cells, brain connections, and learn at school, and they need all the iron they can get. So it's really important to make sure when switching to a vegetarian diet that there's an adequate source of all the micronutrients and you're not missing stuff, because it's very tempting with some vegetarian diets to switch to sort of a lot of cheese or something, and there's a lot of fat in there, there's a lot of calcium admittedly, but there's also not a lot of other things.
All right, we've got Giles on the phone. Hello, Giles.
Hello.
Hello there, you're through to Dr. Chris. What's your question?
The question I was going to ask is, which is the longest planet from Earth? How far is the longest planet? The last planet.
The distance to the furthest planet, well, it was a planet, but it's not anymore. But Pluto, of course, is a planetoid, a little sort of dwarf planet on the outskirts of our solar system. It's actually about 6 billion kilometres to Pluto, so it takes light 6 hours to get there. So if you were to send a radio signal from the Sun to Pluto, it would take in the region of 6 hours before you got an answer. So a radio programme would already be 6 hours old. If you were tuning into the Sue Marchant Show or Ask the Naked Scientist on the Sue Marchant Show, it would take 6 hours. So can you imagine having a conversation? Because if I said something and then you were going to say something, you'd have to wait 6 hours for me to say something. I'd then have to wait 6 hours to hear your answer. So the whole conversation could take a 12-hour round trip. And you think, that's just our solar solar system. And our solar system is in just one tiny corner of the Milky Way, which is our galaxy. And our galaxy is 100,000 light years across. It's absolutely massive. There's 200 billion stars in it. And that's just a tiny component of the whole universe, which has got 10 to the power of 22 stars in it. So you've probably got to times that by 5 to get to the number of planets in it. So on the scale of the universe, it's cosmologically huge, isn't it?
But the planet near to Pluto, which I can't remember which one that is.
It goes Mercury, Venus, the Earth, then Mars, and then you're out to Jupiter, Saturn, Neptune, or Uranus, Neptune, and then Pluto. So it's Neptune that's out there.
So Neptune, then. So how long would it take you if you were going to take a rocket from Earth to go all the way to Neptune?
Well, if you were to try to blast off over there, it would take you a very long time. The way scientists actually do this is by a number of tricks. One of them is a slingshot effect. So you'll have heard that what they do when they want to launch a probe is to aim at a planet, and the gravity of the planet pulls on the probe and attracts it, so it accelerates the probe. But then by the time the probe reaches the planet, because it's orbiting, has got out of the way. So this means that you get a free pull for nothing. So they combine a bit of thrust from the launch, plus they use gravitational slingshots, and this gets it up to a certain speed. I don't know how long it would take you to drive a rocket from Earth to Pluto. I think it would probably take a number of years. But, for instance, I can give you the example of the Cassini-Huygens mission, which took off from Earth in 1997, and this was heading for Saturn, and it was going to put the Cassini orbiter in orbit around Saturn to study Saturn and its moons, and it was also going to deploy the Huygens lander, which was going to come down, and it did come down, on the surface of Titan, Saturn's largest moon. That did not arrive in the Saturnian system until 2004, so it took 7 years for the Cassini-Huygens probe to go from Earth out to Saturn. They've just launched in the last couple of years a probe called New Horizons, which is actually going to Pluto, and it's actually the fastest space probe ever made. And the way that works is it uses an ion drive engine. What this does is it spits out particles from the back of the craft, and because of Newton's third law, for every action there's an equal and opposite reaction, if you push out a particle from the back of your craft, then the craft gets a nudge in the opposite direction. And so it's slowly gaining speed as it's going along, and this is accelerating it in the direction of Pluto. So it will reach a very, very high speed, but it's still going to take a number of years, I think, to actually get there.
I was actually going to ask him if there are any other planets after Pluto or anything, if there was.
It's almost certain there are, Giles. We only recently discovered that Pluto has a number of other moons. People knew there was one moon called Charon, Charon, not Sharon, Sharon. And they knew about Charon, but then the Hubble Space Telescope in about 2006 was used to examine the orbit of Pluto, and 2 new tiny moons popped up. Then there were called P1 and P2, because scientists are boring like that, and they spotted these 2 new moons. They've also discovered things called Kuiper Belt objects, KBOs, which are out beyond Pluto, which are potentially absolutely massive. So that's why New Horizons, that probe, is going to Pluto, because we think out there somewhere is stuff which is probably a lot bigger than Pluto and a lot more interesting.
Bless you. Thank you very much, Charles. Take care.
Bye.
We've got Ian on the phone. Hello, Ian.
Hello there.
Hello, you're through to Dr. Chris.
Hello there, Chris.
Ian, hello.
Oh, Chris, I wonder if you could help me with some ingredients in a loaf.
Go on.
Right. It doesn't say hydrogenated, it just says vegetable fat. Well, I know hydrogenated fat isn't a lot good for you, is it?
No, I mean that's we were talking about unsaturates earlier, where you have double bonds between carbon atoms, and to hydrogenate something, what they do is react it with a stream of hydrogen or a source of hydrogen, and this saturates the bond, so it adds hydrogen across the double bonds, so you get single bonds, and this turns an unsaturated fat into a saturated fat, which means that instead of being an oil, for example, it becomes more like a solid, a fat, and so it's a way of making things like margarines from oils, but in the process of making them saturated, it makes them less good for you.
Right, well, see, normally I look for vegetable oil in a loaf. Hopefully that's not too bad for you.
Well, vegetable fats are good for you. Olive oil is very good for you. That's a monounsaturated, and other vegetable fats like the stuff you get from rapeseed, canola, is polyunsaturated.
But normally, though, Chris, I'd look on a packet and it'd say vegetable oil, and I'd say, great, perhaps it'll be a bit of sunflower oil. or a bit of olive oil, but this says vegetable fat.
Well, I don't know the product you're referring to, but it's possible that if it says plant fats, as plants don't make fats, they actually make oils, it's likely that it probably is some kind of hydrogenated oil. That's right.
Oh, right. So vegetable fat, if it's, made from a fat, not an oil, perhaps that's not too good to eat on a regular basis?
Well, I don't know the product you're referring to, Ian, so I'd be speculating, but I can say that if they've hydrogenated vegetable oil, it's made it less healthy.
Right, yeah, I thought it was much, mate. And the other thing, Chris, if you don't mind, how bad is this stuff? Mono and diglycerides or fatty acid? Because I believe fatty acids ain't supposed to be that good, are they?
Well, fatty acids are not too bad, actually. The way in which the body...
Sorry, go on.
The way in which the body makes fats is that you have fatty acids, which are chains of carbon atoms, and at one end of them is what's called a carboxylic acid. It's a carbon atom with a double bond to an oxygen atom, and then there's a OH group, and that has acidic properties, and so that's called a fatty acid. And the body takes 3 of those things and links them to a molecule of glycerol, which is a sugary alcohol, and it forms what's called an ester linkage between the fatty acid and the glycerol, and so you get triacyl glycerides, or triglycerides for short. So actually they're not too bad, because that's the standard thing you'd find in the body, so just because they're there, you can't say they're bad for you or not. They're quite natural.
Right, Chris, thanks very much. How the hell you know all this, mate? I've got no idea. I don't know how the hell you remember it all.
I'm a geek.
See you around, everybody.
Now then, Oggy in Norwich says, how long will it take Santa to deliver to all the houses in the world at the national speed limit?
More time than it would take, well, more time than any of us are going to live, because there's 6.7 billion people on Earth. If you assume that if you call that 7 to make the war, let's call it 8, because we're thinking about population growth. So if there are 8 billion people on Earth and 4 people in a household, then that's at least 2 billion households. And if Father Christmas has got to land on every single roof and then come down every single chimney, then you can work out that it's going to take at least 4 billion seconds if he just takes a second to do each one. And 4 billion seconds is a very long time. So there's no way he's going to be able to do that unless he uses a bit of Father Christmas magic.
You've lost me. Dave in Great Yarmouth, he says there was some footage of a blue beam and a huge swirl effect in the sky in Norway. Have you seen that, and do you know what it is, or do you have any opinions on it?
Yes, the footage was really startling. What happened, it looked a bit like a whirlpool, but in the sky. And people thought they were going mad because there was this light blue whirlpool effect which started in the middle and then got bigger and bigger and bigger. Imagine that you started with your fingertip, your index finger, making little circles, and with every circle you made a spiral that got bigger and bigger and bigger, so the circle got larger, a bit like a whirlpool but in reverse. That's exactly what people were seeing in the sky over Norway. It was last month. And of course, people took pictures of it, and very quickly on YouTube, video footage began to appear, and people are going, oh my God, is this some kind of alien invasion or something? You know, what is this? There's actually quite a good analysis of that on a couple of blogs, including the Bad Astronomy blog. And the people there have looked at the footage, and they think this was probably some kind of rocket that went out of control. They think that the Russians launched some kind of rocket, and the rocket went up over Norwegian airspace, or very high over Norway, and for some reason it then lost control and it began to have this eccentric spinning or spiralling motion, and that's why it developed this very big trail of material, and that's what produced the effect. So it was basically a rocket spitting out lots of particles in its wake which reflected light in the sky, made it glow, and at the same time it was out of control, so it spun.
Wow. Ooh. Now, Hedra, who thinks that you are lovely, she's from Linton. She says she broke her 12 vertebrae 2 years ago and now has to take andronic acid once a week. As it's been 2 years since the accident, can she stop taking it, and is it worth it?
Oh, you should never stop taking a drug unless advised to do so by the person who's looking after you from a medical point of view. Alendronate, or alendronic acid, is what's called a bisphosphonate drug, and it's used to treat osteoporosis, or diseases which lead to bone erosion, or the weakening of bone. So what it does is it stiffens up bone, or it strengthens bone against erosion by a class of cells called osteoclasts. And osteoclasts are cells that break down bone and liberate calcium into the bloodstream. And in people who have problems with bone remodelling, these include people who have Paget's disease and mainly people who have other bone-thinning disorders, such as people who take lots of steroids or people who are older and may get pathological fractures and things. They take alendronic acid because this prevents the bone from being broken down by these cells, and that keeps bone stronger and it reduces the risk of getting fractures. So it's really important to talk to the rheumatologist looking after the person and make sure that they're comfortable with whatever the decision is. It's not very pleasant to take alendronic acid because you have to stand up when you take it, you have to swallow it with a big glass of water on an empty stomach, and you mustn't get it stuck in your esophagus. That's why they advise you to do that, because it can be a bit of a nasty drug. So that's why it's a good idea to make sure you follow the guidance when taking it appropriately, but definitely talk to the physician looking after the person to make sure that they're comfortable with the course of action.
Yeah, my mum has to take it, and she really goes. She finds it a real trial and tribulation. She does.
But it is an amazing drug.
Yes.
It's amongst in that class of drugs, it's amongst the best, and that's why doctors are very keen to see people use it, because we know it has a very good evidence base and is very, very well received. When it actually works, it does a very good job.
Now we've got David from Canvey Island on the phone. Where is he? Good evening, David. Hello.
I wanted to ask Chris if he could tell me why at the last two properties that I've lived at, my fire alarms, they seem to give a tiny little flash every 40 to 43 seconds.
Is this the little LED on the fire alarm?
That's right.
I thought the idea of that, and I might be wrong, but I thought the idea of that was that then you knew the fire alarm was in working order. Because although they peep when the battery is going flat, if there's no other readout to warn you that the fire alarm is functioning, then you wouldn't know that you could rely on it. Whereas if it just gives a little flash of red light now and then, you know that it's working, you know that the battery is not dead, and you know that if there is a fire, it's more likely to alert you. And a red flashing light is the best way of doing it without upsetting you, because that peeping noise, when either the thing goes off or, worse still, when the battery is going flat and it does it intermittently, is the most aggravating thing in the world, I think.
Oh, thank you.
All right, take care.
Bye-bye.
Bye-bye. We've got John on the phone from Warrington. Hello, John.
Hello, sir.
You're through to Chris.
Yeah, hi, Chris.
Hello, John.
Right, what causes cellulitis, and how long can you keep taking antibiotics to clear it up? And when can it be cleared up?
Well, cellulitis is infection of the subcutaneous tissue, and this is quite common, and it can be life-threatening if you have a severe case of it. It's also very easy to treat, but it must be taken seriously. But it can be very trivial, and it can be something as simple as if someone's got say, an infected bite and it spreads out on the skin. That can be called cellulitis as well. Obviously, that's not as serious as if someone has got the whole of the bottom of their leg affected. I've seen patients who have from toes to knees on both legs affected. And the way you know this is happening is because the tissue gets very red, it gets swollen, it gets very, very sore, and the redness spreads. And what doctors will do is they'll get a marker pen out, and it looks like they're going to do some kind of abusive thing and graffiti all over you, but they will draw around the margin of the redness.
Yep.
And they use that like a tide mark. And if the infection continues to spread, it will obviously go beyond the pencil or the pen line. If the treatment that you receive is working, then it will recede away from that pen line and get better. What's actually happening, it's usually a class of agent called Streptococcus. It's usually Streptococcus pyogenes is the class of organism. It's a group A Streptococcus, and it secretes various enzymes and chemicals that enable it to break down subcutaneous tissue and work its way through the tissue. The bacteria like this environment because it's the way in which they are able to break down tissue and get nutritional things that they need to grow. Obviously, what it does in the process is damage the tissue. The treatment, if you have a severe case of it, is intravenous antibiotics. Thankfully, things like penicillin work very, very well. And if you are given penicillin rapidly, and the agent is penicillin sensitive, there are other drugs you can use if it's not, then you can very quickly make it better. You should always complete the course of antibiotics, because the one thing that you must make sure you do is to clean out all bacteria, because when you have an infection, all bacteria in there are not identical. There will be some which are a bit more robust. They may have some genetic changes that make them a bit less sensitive to the antibiotic than others. Yeah. So when you take the antibiotic to start with, all the vulnerable ones will just die straight away. But there may be a few resilient ones. There may be some bacteria lurking at the infected site where the drugs don't penetrate quite as well. And if you don't take the full course, there's a chance they could be left behind. So you have to complete the course because that makes sure you do a clean sweep.
Yeah, right, OK.
All right, John. No.
Bye.
All right, bye-bye. We've got Jackie who sent an email to us, Chris, and she says sunspots seem to be occurring more often. Why is this?
Well, sunspots are... well, the reason they got called sunspots is because when astronomers began to look at the sun, they noticed that the surface wasn't uniform. And this goes back many, many years, hundreds of years. And they saw that on the surface of the sun there were some dark areas which were apparently cooler than adjacent areas. And these are sunspots, and they are disturbances in the surface contour of the sun, and they appear over an 11-year cycle. So they grow in intensity over an 11-year cycle, and then they recede. And then the whole cycle starts again. So they get more and more numerous, they get more and more vigorous, they get bigger over 11 years, and then they disappear, and the whole thing starts again. And it's because the sun actually has its own pattern of rotation. The sun itself is spinning, but interestingly, the poles of the sun are spinning at a different rate to the circumference, the equator of the sun, and so the sun screws itself up effectively over time and then has to unscrew itself again, and this is what we think culminates in this altered convection currents in the sun and this altered surface temperature contour, which is what produces sunspots. They're associated with other manifestations, including things like coronal mass ejections. So the sun can suddenly sort of splurge out material into space, and this can travel through space towards the Earth as this million-mile-an-hour maelstrom of charged particles, which will slam into the Earth's ionosphere, and these are the Earth's magnetosphere, the magnetic field around the Earth, and they will produce beautiful lights, but they will also impact and they will also change the behaviour of the Earth, and they can do things like seed clouds. Scientists have discovered that these showers of charged particles can actually help to make clouds form. So when you have lots of sunspots, you can actually get more clouds forming because the charged particles help clouds to get started in the first place, and that then can produce more rain. And scientists have done studies in Africa, and they have been able to look at the tide marks in some of the big lakes in Africa, such as Lake Tanganyika in East Africa, and what they've found is that the tide marks, going back hundreds of years, follow an 11-year cycle, just like the sunspots do. So it's showing that sunspots really do seem to be able to influence the Earth's weather. They influence rainfall, and this has fairly dramatic effects on the large scale on Earth's hydrosphere. In other words, how much water there is in the water cycle at any one time.
All right, lastly, Chris, Tad has said, is there any way that damaged arteries can repair themselves?
Well, arteries, when they get damaged, usually are damaged by the process of atherosclerosis. Obviously, arteries can be injured by surgeons and by accidents, but usually it's because of the progressive and inexorable furring up of the artery by the deposition of things like cholesterol and fat in the wall. Now, the usual outcome of that is that the artery progressively narrows and narrows and narrows, and eventually a blood clot can form at the narrow point and block the artery completely. And if that happens, it can then cause all kinds of problems for tissues downstream. If it happens in the brain, it can cause a stroke. If it happens in the heart, it can cause a heart attack. But when a blood vessel blocks like that, it doesn't mean it's curtains, because as long as there are other ways for the blood to get to the tissue that's supplied by that artery, it doesn't mean the tissue is necessarily going to be jeopardised. But over time, what can happen is that once you've got a blood clot sitting there, cells can move in and begin to erode the blood clot and then recanalise it. So you do eventually restore blood flow to an acutely blocked vessel, but there are limits, and many of these blood vessels in people who have very bad arterial disease can be more than 99% blocked by fat. So even if they do recanalise, it's very, very difficult for the flow to be restored to any meaningful level, and really it needs the help of a cardiologist or a vascular surgeon to get in and fix the problem.
That's it for this week. Our doctors will be back with me next week for more Ask the Naked Scientist. But don't forget, you can also catch them on the Naked Scientist podcast, which you can find on the Naked Scientist website, www.nakedscientist.com.
The Naked Scientists comes to you from Cambridge University and is supported by the Wellcome Trust, the EPSRC and UK Fast. For more information, look us up online at nakedscientist.com.